Hello. This collab explains modern computer vision models, starting from attention and vision transformers, then moving to Clip, Dino V2, SAM, Connext, and Swing Transformer. I will start with this particular cell, which imports PyTorch and checks the device. The notebook ran with GPU support, we can see in this cell. And then next comes the attention mechanism. This cell explains scale dot product attention using a query key and a value. Then if we go ahead and see cell 5 then extends into multi-headed that into a multi-headed attention where different heads learn different relationships. So this is the whole cell, and we can see how like a different heads learn different relationships with these different values. Next is visualize attention patterns. In this cell, we visualize how attention heads focus on different positions. If we see through this graph, there are like multiple graphs that are given, and we can see like how attention to heads like focuses on the different positions. Next is Select, which converts an image into patches, like turning an image into tokens. We can see here how images of different sizes turns into tokens. And next is visualize the patch grid. This is how the different values that I'm assigned values that are assigned, and then we can see how it can visualize the patch grid. Next, cell 10, this defines the transformer encoder block, and then we can see the different inputs and then what is its respect outputs and what are the parameters given. And then this cell 11 builds the full vision transformer with innate weights, which is trunk normal, and then I would key trunk normal, and then we'll go forward, and then I'll do patch embedding and all those, and then we can see the respective output. Then here we'll compare the VIT variants, and here are the different configurations like model layers and heads, and then these are the different variations, and these are the VIT model variants that we can see with respect to each model. If I take VITS, it comes out to be 384, 12, 6, 22, 50, and 64. So these are like different hidden layer heads parameters that we can see. Next is 14. In this section, this explains clip for zero shot classification. Here we can see like the clip connects images and text, so we can classify images using text prompts instead of training a new classifier. And this is the whole classification which is showing up here. And then here is the notebook that loads Dino V2 and explains self-supervised visual features. Dino V2 learns a useful image representation without needing manually labeled data. So this is the output for it, and these are the Dino Model 2 variants. These are the models, their IDs, architecture, params, and dimensions. And next is segment anything model. This section explains segment anything model. SAM is used for image segmentation, where the goal is to identify object regions or mask in an image. And this is the SAM model output, and this is an example. And next is the hybrid architectures. This cell introduces Convert Next, which modernizes CNNs, and cell 23, which is next one, introduces Swim Transformer, which uses window based attention to make transformers more efficient for images. Next is this is the final part, which is selection guide and cheat sheet. And this final cell summarizes which model to choose for different tasks and compare pre-trained model and provide quick start snippets. And the main takeaway is the modern computer vision uses both transformer based and hybrid architectures depending on task and efficiency need. So this is the final vision transformer cheat sheet that's been printed for the cell that we have given here. That's it with this notebook demo. Thank you.